I am pleased to be invited here for Altium's AltiumLive conference here in Frankfurt. I was in San Diego a couple of weeks ago doing a different presentation, but I was excited for the opportunity to travel abroad and come to this presentation. My name is Kelly Wigington. Even though I'm wearing an Altium shirt, I work for another company. I just wanted to have the credibility of wearing one of these shirts that I bought at the store earlier. Anyway, I'm the director of the PCB design for my company, VPI Technology Group, which is an engineering consulting company in Salt Lake City, Utah. And I love using Altium Designer to design our printed circuit boards. And so since I have formed a local user group and been active in presenting there, Judy invited me to present at some of their AltiumLive conferences, which is a great opportunity. So Dave Habood and I today are going to talk about making the most of the design rule capabilities in Altium Designer. So first of all, what I would like to ask, just for kind of a demographic poll, is how many of you here are electrical engineers? Raise your hands, please. A big number, as I expected. Are there any mechanical software engineers here? How many are PCB designers? Or, as Jeremy Bloom would call us, PCB design artists. Doesn't it feel good to be an artist? That's good. We got a good mixed group here today. Now, I want to know how many of you, how long you have used Altium Designer. So how many 1 year or less? That's good. You'll pick up a few things here, I hope. How many 3 years or more? How many 5 years or more? Oh, very good. We got some big long timers here. All right. So I want to know what version of Altium Designer you're currently using. How about those that are using AD19, the latest version? Most everybody, that's a good sign too. Altium Designer version 18. Okay, how about 17 or earlier? Okay, a few of you. And all I would do is encourage you to keep current, because Altium Designer does rapidly improve their products and fix their bugs as well. So it's always good to be on the latest version. Okay. How many of you have experienced some frustration with the DRC syntax? Okay, that's the hands I want to see. Okay, we're going to help you out today then. Now, how many of you have seen this document? It is a query language reference for Altium's DRC syntax. 349 pages of syntax information. How many of you are excited about looking through that to find the syntax you need?
Mel? Oh, sorry, just me.
For your design rules.
That's the ex-software engineer in me.
So you love to read this stuff. Great, Dave. Great.
They do pay me to read it sometimes.
So the goal of this class is to help you avoid having to look up all that syntax and make the design rule checks relatively, or really very easy. I'm going to show you some tips and tricks how to do that. First of all, if you go into the design rule manager, and now it's called the design constraints manager, yeah, rules and constraints. It's too long for me. I'm just going to call it the design rules manager, because that's what I'm accustomed to. Anyway, when you go in here, one of the first things you see is we have a query helper. The query helper enables this list down here at the bottom, where you still have a list of all the syntax, but it's in a readable format, and it's sorted by categories to help you out a little bit. That's not a big improvement, but I found that the query builder, which is the next button, it allows you to enter conditions, which makes it easier to get your syntax correct. So in this case, I select from the first column, I want to define something that exists on a certain layer, and then it gives me on the next column all the layers that are currently available in my PCB database to act upon. So that way I can narrow down and format my syntax easier. I want to show you another really great way to do it with the PCB filter. And as an example in this case, let's say that we have a fiducial and we need to back the copper plane away from that fiducial by an additional amount so that the optical equipment can recognize that easier. Now, first of all, in our design rules, we have a minimum back off that is used for all the pads and elements on this top layer. But for our fiducial, we need to increase that further. So how would we set a design rule that would make the copper pour back away as much as we wanted to? So what we can first do is select the pad or the component there, and then by clicking the right mouse button, bring up our context-sensitive menu here to find similar objects. Once we do the similar objects, then it takes us to this dialog box where it shows us all the elements of that particular pad. And as you're familiar with, we select same for any of those descriptors that we want to sort by. In this case, I just went down to the library template because I knew it would be unique for the size and shape of my fiducial pad. Click same. Now, the thing to remember here, although you've used this many times, you want to make sure and check this box down here that says create expression, because then what happens is it opens up the PCB filter, and in the PCB filter, it gives us an expression for defining that particular pad in a unique way, as in this case by the pad via library template. Okay, now from this dialog box, we click on the button that says create rule. And what happens next is it asks us what kind of a rule do you want to create. In this case, since it's a back-off rule, we select clearance constraint in the design rule list, and it creates this design rule automatically for us. So it puts in our clearance rules, the clearance, we give it the name that we want, and I encourage you to use a descriptive name that you can recognize and understand when you come back to your design rules later, or if you pass that design off to somebody else, that they can come back in and quickly and clearly understand just what each of these, the purpose of each of these rules is for. Okay, so with our syntax in here, we can make our second object just match all elements. In this case, it'll be the copper pour, but we also want to keep other traces and things away from there too. And we can give it an additional clearance of 25 mils around that fiducial pad. So now, once we repour our polygon, it abides by that rule that we just created, and now we have a bigger void around that pad. Now, obviously, we could use a keep out to put around there. That takes more time and more effort, and it's something that has to be replicated time and time again, where in the design rules, this will always be there. And if we can save that off as a template, we never need to think about it again. If you have any questions, go ahead and just raise your hand while I'm going through these. The next rule that we would like to do, or that I would like to show you, is how to create a board edge back off for your polygon pours, or also a keep out for pads, traces, and other elements from the edge of the board. Primarily, I want to use this as a clearance for the polygon that I'm going to pour, because as you'll see, this is an unusually shaped board, and to create a copper pour that just blankets and fills in the entire board with ground plane, as is my objective, I want it to just very carefully follow the edge of the board and the curves. So another of my design rule, it's under the manufacturing category. I add a board outline clearance. It gives me this whole big table of design rules or backoffs for pads, vias, tracks. I'm going to focus on the polygon column here and tell it that I want a back off of 20 mils from the edge of the board for my copper pour. Now, that's for my outer layers. I can also have a separate back off rule for my inner VCC layer. Let me just mention, my layer 2 is a negative or reverse image ground plane. So since I'm not going to have copper pour on that layer, I don't need to set a rule for that. I do it in the layer stack manager by specifying the pullback, if you're familiar with that. Okay, so here I want to set for my VCC oops, I hit the wrong button. For my VCC layer, I'm going to increase the back off to 25 mils instead of 20. Why would I do that? Well, when I did this presentation in San Diego last year, a common practice in our company is to avoid the fringing effect around the outside of the board. Any of you ever heard of that? If not, that's okay, because when I presented in San Diego, I was fortunate enough to have Rick Hartley in my class, and he said, bah, that's fringing effect is not even a real thing. He says, don't even worry about it. So anyway, I was just like, okay, sorry. But if you wanted to have a separate clearance for your internal and external planes, as is reflected here, you could do that. But it's not necessary for fringing, because I take Rick Hartley's word on it that it's not really an issue. Okay, now, while we are talking about polygons, let's talk about another rule we can use to control our polygons. We want to have our polygons, our copper pours, as I'll refer to them, we want to have thermal relief connections on our through-hole pads and our surface mount pads. Now, if you're using version 17 or earlier, you didn't see the advanced features that came out in 18 and 19, which allows you to do a separate thermal relief spec for each of these different pads, your vias, your surface mount, and your through-hole pads. That's really handy, because before, you'd have to create 3 separate design rules for each of those. And of course, you don't want a thermal relief connection on your vias, because those don't have to have anything soldered to them anyway, so there's no heat dissipation concerns. Anyway, with the advanced rule, you can do all of this in one DRC rule. So after setting that, we think, well, there are occasions where we have polygons that we want to flood the pads, not thermally relieved. We want maximum current carrying capability, even if the manufacturer doesn't appreciate soldering the components to those polygon flooded pads. Anyway, so we create another rule, and the syntax is this, is named polygon, and I've created a name for my polygons. I call it no thermal. That's just an arbitrary name that I made up, but I can name my polygons and then use those in the design rule syntax here to tell it when I have a polygon with that name, there will be no thermal relief pads, just flooded into the copper. Now, again, this syntax is a little bit complicated, but I'll show you where to find that, how to create it in an easier way. So here is an example of a polygon that I want these 12-volt traces to be just heavy flooded copper. Here in the properties dialog box for my polygon, I have the option here to give it a name. I call it no thermal, and then it will reflect that rule that we created in the design rules. Now, I want to talk about the Polygon Manager, because here's where it can save you some time and assist you with creating these rules again. I might have put this slide before the others to just show you how to create that rule, but without knowing the syntax, you come into your Polygon Manager here, and you have these 3 buttons. Now, in version 19, there's an additional button included in that as well, which I'll talk about, but it's not created in this slide. First of all, I select any of my polygons that have the no thermal name, and in this case, it's highlighting that one that I just showed you in the previous screen. Now I click this button that says Create a Polygon Connect Style Rule for a polygon that's named no thermal. And we go back, it creates this design rule that I just showed you. It automatically put the syntax in there for me, no worries. I put the name, a descriptive name in here, and then tell it I want all of these direct connect. Works out very nice. Now, some of you may be thinking, well, why don't you create a rule that says thermal and not no thermal? Well, I did try that the first go around, but what I learned from that and what I want you to understand is you want your default rule in any of your categories to just kind of be the catch-all. So if it doesn't meet this criteria and this design rule, goes to the next, down the hierarchy or the priority list. And your last catch-all rule is going to be what happens default if there's no name or other requirements for that particular element, clearance, thermal, or clearance, polygon, otherwise. So because I want thermal relief pads on everything by default, then my exception is going to be a no thermal rule, and that's why I did it that way. Okay, so now, still on polygons, I want, yes, a question?
Why don't you use Polygon Class? Because then you can make names for maybe power level layer 6 and so on.
Okay.
I just ask, why don't you use the Polygon Class feature? Because then you can name it better, like power 3.3 layer 6, whatever, and then make a Polygon Class, no thermal, and put them in the Polygon Class and make a rule for the Polygon Class.
That is a good suggestion. And if you do have like multiple classes of polygons, that is very useful. In this case, making a class for that particular no polygon rule, it's not saving me any extra design rules, but we are going to talk about classes and putting things in categories for our design rules, which is not only time saving, but it keeps your design rules much cleaner. So good suggestion. If you do have a bunch of elements that need to be grouped together so that you can create one single design rule to cover all of them, then that is useful.
We'll show the board at the end, and it's a simple board.
Yes.
So that's a great suggestion if when it gets more complicated, but remember, keep it simple.
Yeah.
Right? So,
Sometimes classes help keep it simple,
Right.
and we're going to get into that discussion here. Okay, so anyway, I've got my ground fills that just are going to blanket the entire board with ground. Of course, I'm going to stitch it through the layers to keep the ground balanced and quiet. And in this case, I want that to have another unique name called ground fill, because while my minimum back-off spacing for my polygons, other tracks and elements is 5 mils, when I'm just covering the entire board, I want to give the manufacturer just a little more tolerance there. So in this case, you notice that with this ground fill rule, I have increased the clearance or the back off to 8 mils, which just provides a little bit extra tolerance for the manufacturer. Okay, so now let's talk about priority. When you end up with a bunch of clearance rules in here or in any of the categories, things can start to get confusing, because it could be that one element meets the criteria for 2 of your rules, and whenever it hits the first rule that it qualifies for, it's going to act on that rule, and then you may get erratic results if you don't have them categorized properly. So down here at the bottom of your design rule manager, you have this priority button that allows you to go in, increase or decrease the priorities of your rules so that you get the results that you want. And as I mentioned, you're going to have the default clearance rule always as a catch-all at the bottom, so that no matter what happens, you're always going to have, in this case, a minimum 5 mil clearance no matter what.
Yeah, so if I'm sure most are familiar, but whichever rule criteria is met first, that one is executed. So anything below that won't be executed. So you have to make sure that it is prioritized correctly. That's why that you want that all at the bottom. If you have prioritized it incorrectly and you somehow put that all at the top, all of the ones underneath don't matter, right?
And sometimes I don't think logically about how those should be prioritized. So I'm thinking, okay, how come this rule doesn't seem to be working? And it's a priority issue. And so I admit sometimes I go in and I just kind of adjust the priorities until I get what I want and see that it's working. And then I know that they're being handled properly. So anyway, that's how we manage the priorities. Okay, now let's talk about something a little bit more complicated, like differential impedance controlled routes. So in our list, in our design rule manager, we have these settings for differential pairs routing. Now, when you think of the design rule manager, some of the design rules in here are for checking to make sure that all your clearances and that are correct. But Altium also uses some of these settings to actually control your polygons, in this case, your routing. So this particular rule is not to check for errors or violations. This is to define the trace width and separation of your differential pairs. So I've created 2 routing pairs, and these are actually based on classes. So I'm going to demonstrate how we put those into classes in that screen in just a minute. But I have 2 different rules, one for my 90 ohm differential pairs and one for my 100 ohm differential pairs. For each of those then, I define what my minimum width and gap, and I want it exact, so I just make them all the same, 4 mils gap and 5.5 mils trace width. And I'm not intending to use the inner layer because I haven't calculated for that, so I just leave it at 0. Now, I think with Altium 19, when it came out, it wouldn't allow me to put zeros in here, so I had to go put in an arbitrary number like 1. But it just tells me that I haven't calculated the inner layer differential pairs and don't intend to use those. Okay, so let's go see how to calculate our pairs. Now, if Rick Hartley was in here now, he would say, don't use the online calculators, you need a field solver. But if your boss won't buy you a field solver like mine, then you have to get by with what you have available. How many of you have used the Saturn PCB design calculator? It's a popular one, and I think it is useful. But you go in there and you set your target at 90 ohms, and you play with these numbers a bit with your conductor height, which is in this case the dielectric thickness, and you just test these numbers out until you get close to the target that you want, and you go, okay, that's good, I'll go with that.
So this is what I was saying in 19 with the impedance profiles on the layer stack. We included a field solver.
Yes.
So now in Altium Designer 19, you can do a lot of these calculations internally, and it will automatically do a lot of this stuff. So you can double check it if you want. We partnered with a company, Symbian, to incorporate the field solver, but it gives you the same results. So, you know, you could, I know engineers like to double check things. Let's be real.
Version 17, I also see that you can calculate it.
Yeah, well, this now includes a field solver, right? So it's built on that system, so it's more. So now we improved the layer stack manager, and now there's impedance profiles on top of all of that. So it's a lot more, and you'll see we could at the end we're gonna have like 30 minutes after all the talk. We could look into stuff. We could pull up the layer stack manager or look at the impedance profiles. I actually haven't worked too much with them because I focus on rules in general and Concord Pro, but we could take a look,
Yeah, I'm interested, and I
play around with them.
should have asked you before, but how does the integrated Altium field solver compare with some of the more expensive ones that are available?
So like I said, we partnered with Symbian, so that, you know.
So it's as good as their.
They say they tested it against Saturn, so
Okay,
that,
good enough.
you know, I didn't do the personal testing. So.
Jeremy, what was that?
I compared it with Polar. I did a bunch of the field solver
Uh-huh.
comparisons between Altium and Polar, and it's all extremely close.
So
Good
thanks,
to
Jeremy.
know. Thanks, Jeremy.
We got Jeremy's seal of approval.
Jeremy, I gave a shout out to you when we first started the class. I think you weren't here then, but
Yeah.
I appreciated the fact that you referred to PCB designers as artists.
Yeah.
I said, that just makes me feel more important than I am.
You could actually sell a seal of approval. That'd be pretty awesome, Jeremy. It's like, I'd buy it. Yeah, I'd just stamp everything all the time. People would be like, "What is
Approved
this?
by Jeremy Blue.
What is this?"
Okay, so now, where am I? Okay, here we are in the classes. So under the design menu, we go down to classes, and here is where I have defined my differential pair classes, 90 ohms DP, 100 ohms DP. So any of the pairs, differential pairs that you have defined in your schematic as differential pairs, they would appear in this list of non-members, and you simply push them over into the member list, and now they belong to that differential pair class. I didn't do any slides because I didn't really want to go back to the schematic, but how many of you have used the directives in the schematic to define your differential pairs? Okay.
Oh, that's great.
So just remember, you use the same signal name only with an underscore P for your positive signal and an underscore N for your negative signal. And then once you drop that directive for the differential pairs on there, then that defines them as a differential pair. When you netlist into the PCB, they come in as differential pairs. They appear here in this list, and you can categorize them that way. Okay, so now here is my, we've specified the routing rules for those differential pairs. And remember I said that those rules are going to control when you select the command to route a differential pair. It's going to route them at the correct width and separation, but it is not going to check for the clearances or the width when you run the design rule check. So now we have to go and set a width rule for our 90 ohm differential pair and say, if it's in that differential pair class, I want my width to be 5.5 mils. This is what does the actual checking to make sure that that is correctly maintained. By the same token, you have to go create a clearance rule for your 90 ohm differential pair. In this case, I said the space, and give it the spacing. Make sure that you set this to the the spacing between the same differential pair, the 4 mils, and then when you route, it's going to route them correctly, but if in the routing and placement and editing, you accidentally misalign those pairs, this is what's going to check and make sure that they are maintained. Jeremy?
I don't mean to challenge you, but I don't agree.
Okay.
It does show up as an error when you, like, I've never done what you're describing here. I would just define the diff pair within space, and if I move something, it shows up as an error when I do a design rule check.
Okay, let me mention, I did this presentation, I said last year at the San Diego Live Conference, and after I did the presentation, Michael McSherry came and met with me, and he goes, okay, you know, we want to address some of these issues that you brought up, and so they were going to go back and look at kind of cleaning those up and integrating them. And so in 19, I haven't ever gone back to check to see if that has been corrected now. So I'll take your word for it that it is. So Jeremy, you're saying that as long as you have the rules set up here in the differential pair rules, it will do a DRC check to make sure that those are maintained.
Yeah, you have to, when you're configuring the DRC check, you have to make sure that you explicitly tell it when it's doing bad DRC to check this. But if you do, it will complain
If they're not. Okay, good information, thanks. Okay, so now that we have set up the settings for our differential pair routing, we can just go select the, it's not here on the menu, but the icon for the it's called differential, interactively route differential pair connections. I select either of these pads and it knows that they are paired and begin routing, and it keeps those signals paired together all the way. Now, by default, it's going to do 45-degree angles, right? All you do is hit the shift space bar to toggle to arc mode. And then further, if your arcs are too sharp or too wide, you can use the shift up arrow, down arrow to adjust the length of your arcs that way. Okay, now another thing we need to do is, as Rick Hartley teaches, keep the aggressors away from those differential pairs. Now, because our ground plane is flooded into that area, it's going to give us an 8 mil back off as we define for our ground fill from all elements. And that's not enough to really prevent it from affecting the impedances of the differential pairs. So again, we create a rule here now that says clearance differential pairs to polygon. That's just the abbreviated name that I put in there. And the syntax is in any differential pair, when the second object matches polygon, then I want a minimum clearance of 16 mils. So with that, I go re-pour that copper pour, and it gives me a 16 mil clearance there. And it would do so for any differential pair. So with that rule, it's just global for any 100 ohm or 90 ohm differential pairs that I may have on the PCB. Jeremy?
Is it possible to, is it possible?
Is it, whoa, it's loud. Is it possible to define that back off based on some sort of like variable parameter, or is that potentially on the roadmap in the future? So like, for example, the back off from the diff pair, like one of the rules of thumb is 3 or 4x the dielectric height. Is it possible to do something like that instead of specifying 16 mils? Like I want it to be 3x the height of the dielectric from the stack-up manager or something like that?
That is a really good question. Do you think the syntax would allow that, Dave?
Not right now.
Okay.
But
Should I file a bug
you know where to
crunch?
find me.
Okay.
So for now, you would
send me an
probably
email.
set that for your worst case
I like that.
differential pair, but Yeah, if you could set it for that rule that Rick Hartley gave us, that would be ideal.
At the end of the presentation, I'm showing some work in progress stuff, and yeah, we'll talk after that. Remind me in an email though, because I like that idea. So that'd be pretty cool to put variable type thing.
Okay, next thing, differential pairs are tricky, and now next thing we need to set in our design rule check is we want our differential pair signals to be the same length, or at least within a certain tolerance. So we have another design rule in our high-speed rules called matched lengths. And here we have two different options, and the one that we're going to use is within the differential pair length, which means that we want each of these signals in the differential pair, the positive and the negative, to be the same length, or at least close to the same length. So we set the tolerance here, and then the design rule check will make sure that it is within 3 to 5 mil tolerance of the length of each other. So when we can open up our PCB panel, and there's several different options here in this top box. You can do 3D models, nets, everything. But we want to look at the differential pair editor. Here are our differential pair classes. We don't have any 100 ohm classes in this PCB, but for our 90 ohm class, we have one pair, which is the USB-D. Down here are the two positive, negative nets. And here in this column, it shows the routed length. Now you can see that those are almost exactly right on. If they were skewed somehow because of bend allowances and things, then that design rule check would tell us if they weren't. Now, I brought this up to just demonstrate that if you find that they are out of matched length further than you want them to be, then you can go in and use the command to add a trombone or a little bit of a jog there to match the length on those differential pairs. But the design rule is such that you can set the tolerance and it will abide by that. Okay, next situation that we...
I don't know if they showed, I was practicing in the morning, so I don't know if they showed in 20 the new area movement thing. Did they show that?
So I didn't go this morning because I saw it in San Diego.
Okay.
But I'm not sure what you're referring to.
So that you can just like move the whole area. Okay. Yeah.
Okay. Yes?
Yes.
Yeah.
Okay. I think it was in 2018 where you introduced this differential pair rule helper or creator, which did everything you've shown in like a guided way. Robert Feranek made a great YouTube video. I think it was differential pair routing the old and new way.
Okay.
And all rules that you have shown, it was like just filling out blankets in a window and you're done.
So it's kind of like a wizard to go in and do all that for you.
Right. There's a differential pair rule wizard introduced in Altium Designer 18, I guess.
Okay. And I'm sorry, I'm not even familiar with that. I started doing things this
And
way. And
yeah, I just learned this from Robert from one of his YouTube videos.
okay.
So there must be the wizard. It's still available, I'm sure.
Yeah, thanks for mentioning
Yeah, there's,
that. You can learn everything on YouTube. From Robert Feranek.
yeah,
Thanks.
he's pretty great. I talked to him for like 3.5 hours last week.
Yeah.
we
That's
talked
what
to
I,
him.
that's what I love about coming to these conferences is you meet some brilliant people and get some great new ideas.
Yeah.
Okay, so the next situation that we're dealing with here on this particular PCB is we have a 0.5 millimeter pitch BGA, which means that we have got to neck down our traces to get between those pads. And actually, we have to do a 3 mil trace dead center down the middle of those pads to have, I think, a 4 mil clearance or a 3 mil clearance on each side. Now, we don't want to set our board clearances now to 3 and 3 because we don't want to, well, let me just say from a manufacturer's point of view, they can focus on a small area and maintain some tight tolerances. If they have to follow those tolerances for an entire board, then it gets pretty challenging for them. So what we want to do is just specify some different rules for just this BGA area. And we do that by placing a room, as I've got here, underneath that BGA. There is a command under the design option called rooms, and it gives you lots of different options for creating rooms. Here I have just outlined an area around the BGA where within this room I want to allow it to allow 3 mil trace widths and 3 mil spacing in that area. So after placing the room, now I go to the design rules, and first I go create the room definition, and again I give it a descriptive name that I can relate to. This particular room definition is a component class, and I'm not sure what the logic is behind that, but I won't question it. When you select component class, it gives you a pull-down list of the rooms that you have in the PCB. In this case, I specify it's on the top layer, and I want the rule to be for all objects that are inside that room. So that is the first step in the process. Now I need to go and, using that room definition, go create a clearance rule and say, okay, within room BGA area, now I want to allow a clearance of 3 mils to the SMD pads and 4.5 mils from track to track. And then, by the same token, I have to go into the routing width rule and say, okay, I will allow a minimum width of 3 mils within that room BGA area. And that allows those specific tight tolerance rules in the BGA area while maintaining your higher tolerances and rules through the rest of the board. Okay, now one other rule option that is useful is one they added. I'm not sure what version it was that this was added, but traditionally it checks for all of your trace widths. So you can make sure that all, yes? You got the microphone there.
Excuse me. How about the priority for the special clearance rule for this BGA? Is it on top or much lower?
I can, let's see, I've got it right.
Also, especially what does the checker first flip out of these ruling checks?
That's a good question. I would want to have that prioritized. Now here I've got the clearance right above the minimum clearance, so it's filtering down and hitting that rule. But I probably, since that is a unique rule, I could raise it. Well, do you know what? I do have to have it. Do I have to have it underneath my my differential pair rules? Because in my differential pairs, I have to route those at least at 3 mil width to get under the BGA. So that even at the bottom of the list, it is abiding by the 3 mil rule for those differential pairs. So I think if I had this rule prioritized higher above the 90 ohm differential pair rule, then it would cause me some problems. Does that answer your question or kind of add more confusion? Okay, so the disjoint vertex, I create this rule because what it looks for is the check tracks and arcs width will just search for all your 5 mil. It'll let you know if there's any tracks that are width less than 5 mils, but on rare occasions you have this situation here where you have a disjointed subnet where the vertexes don't meet, and you can see there that you have a smaller neck there. So this rule is with this checkbox to check for those kinds of situations. So you use that rule, and here I have, at minimum 3 mils with the preferred width of 5, and it is flagging that that neck is less than 3 mils, which I would want to go back and correct. So my catch-all width rule just checks for 5 mil width on everything, and it's going to exclude what's under the BGA. But for this rule, I'm going to check for anything less than 3 mils in my vertices. Any questions there? Now, when you run the design rule check and it shows you all the errors that you've got, clearance errors and such, you use the PCB Rules and Violations. Now, again, I'm not sure at what point this was released, because before it was always look under messages and just go highlight them one by one and identify them and remove them. But with the PCB Rules and Violations panel, it categorizes them, and it also allows you to get a better, you can bring up this dialog box that gives you the violation details and what your existing setting is and where it violates the rule. So that is very helpful.
Sorry, can you go back?
Yes.
Another good thing about that panel is that you can go to the class of rule, and then you can batch run those rule types by that class, or you could individually run each rule, right? So you don't have to do the whole, it takes a while sometimes. So if you just want to know a little bit more about one specific thing, you just want to check out one rule type, or just check out violations of one specific type, you could do that. So it gives you that visibility on a nicer level. It pinpoints things. So if you want to do all rules, you can just run them all. You can run one class of rules or individual rules.
That is good to know. I wasn't aware of that, but yeah, it would save some time.
Yeah, and then obviously
in running
navigate, once
that
you
whole
get the
thing.
rule, you can navigate if you're like, oh wait, you were talking earlier, maybe it's failing because your prioritization's wrong. I'm gonna go navigate here and change my prioritization,
Okay.
right? Or maybe I'm gonna waive this violation because this isn't really relevant for some reason, and then I'll have I have a record right here of why I'm going to waive this violation and the time I've waived this violation, and then I can pull a report and document that properly.
You have a question? Wait for the microphone.
When you waive violation, it will appear in the bottom part of this rule. It's also
Oh, yeah.
quite convenient to see everything at once and to waive and unwaive right in this panel. So use it. It's quite convenient.
Yeah, because once you waive a violation, a new pop-up, since it's contextual, there will be a new waive violation area, so that then you can navigate what you've waived, right? And then once you run the rules again, you could make sure that it's relevant.
Thanks. They're really good comments. Since we have plenty of time. Feel free to comment or question anytime during the presentation. I'm just about finished with my slides, and then Dave is going to show what's coming up in version 20, the improvements in design rules,
And beyond.
and what we have to look forward to. Okay, so just my take on design rules is the key to successful design rule integration is to compile a comprehensive set of design rules that you can port from one project to the next. So I create all my favorite, my most effective design rules in one spot like this, and then I'll demonstrate you can export those rules. Trying to remember where I came. Well, I think I just right-click on the design rules here. It brings up this context-sensitive menu. One of the options is export the rules. It asks you to highlight which rules you want to export. I always just do all or nothing. And then, by the same token, you can import those into another PCB database. Now, you could also just save the PCB database as a template for your next job. This just allows you to easily copy your favorite design rules from one job to the next. Just be aware that when you import any rules, it is going to overwrite any existing rules. So first be careful and check what existing rules you have before you overwrite them. And if you were to import these rules into a database that you had, but you didn't have any impedance-controlled routing, so you didn't need those rules, you could go in selecting the header on each of the categories. It brings up this table, and you can go uncheck those differential pair rules. I would advise against this because if you uncheck them, it's not going to be easily noticeable that they are disabled. And then if you do add some differential pairs to the PCB at some point, you're going to think that you're just skating through with no problems, even if you have errors, because they've been disabled.
That was one of the main reasons the ability to individually run the rules in the panel was added, so that you wouldn't have to do this, because people were doing this.
Getting into trouble, obviously.
And then being like, everything's fine. And then it was not fine.
Okay, the last thing I want to leave you with as part of my presentation is a little Easter egg that I didn't discover it. It was shared at a user group meeting that I attended years ago. But if you press the Y key anywhere in your database without anything selected, it brings up this obscure menu of basically scripts that have been created. It has some examples, and one of those that I really like, well, there's several examples of some scripts that some board engineer created somewhere at Altium and just saved them there. But the one that I like is this one that says identify tracks that are less than 2 units long. The units means it can be whether you're in mils or millimeters. But what that does when you select that is it will go through the database, highlight and select all of the little stubs that you get collected underneath the pads and maybe even in the middle of traces. Now, they don't do any harm, so it's not really a big problem, except when you're trying to go back and maybe edit or move a trace. But this just allows you to go in and select and delete all these from your PCB database, which if you're OCD like I am, it's a good feeling to just get rid of those.
Yeah.
Now, because it selected those segments on all mechanical layers everywhere in the database, I thought, oh, that maybe is a little too risky to go that far. I went in and edited it in the PCB filter and said, is track and on signal layer, and then go do the calculation so that it would only select them on the signal layers. Then, after modifying that, it's in my history tab. And then I simply went and clicked Add to Favorites. It added it to my Favorites tab. And now when I press the Y key, it's right there at the top of my pop-up context-sensitive menu. And I just run that, and goodbye to all those stubs. Out of mind, out of sight. Okay, that concludes my portion of the presentation. So now Dave gets to show you all the
Took
exciting
off.
things. Boy, that really took off.
Okay,
you.
so you could change the volume.
Okay.
With that?
Sorry for interrupting. Could you go back one slide, just before?
Yeah.
For this calculation.
Sorry,
there is,
who's talking?
Me is talking.
Oh, I was
Okay.
like, yeah.
Okay, for this calculation, there is a function inside Altium. It's called trace length. It's not well documented, but there is in AD17.
Okay.
It was. And you can use that one, and it's a little bit faster.
The script you're referring to?
Yeah.
Okay.
It is called trace length.
Okay. Where's that
Yeah.
command located?
I had some big time finding that, but I found in a script on the website.
It's a script on the website.
Yeah, it was mentioned there, but there is a native function. It's like width or this kind of issues, and it's
Okay.
called trace length.
Okay.
It is very funny because usually you refer to the lines as being track, not trace.
Yeah, I guess it really depends.
Yeah, but that function is
Yeah.
this way.
Okay, thank you. So I wanted to start off with just a quick discussion. So after everything we've seen, out of everything, what do you guys feel has been the most useful thing for you in terms of rules and constraints for getting things done? Things that come up often are the ability to have this prioritization, this hierarchy. I didn't want to put too many things up there because I don't want to prime people answers. So I just kind of wanted this to be an open discussion to get started. So just anything.
I think the class functionality is really good.
The class functionality? Okay.
And order stuff in classes that make rules for.
Okay. Okay. Anybody else?
You get tickets if you make comments.
It's true. Did they give us tickets? Where are the tickets?
Like maybe I shouldn't say that. Or I might get
She
in
has the
trouble.
tickets over there.
You have tickets, right?
Uh-huh.
Okay.
Yeah.
Thanks.
Coming from another tool, what really is cool that when you have a class that you can highlight them,
Highlight the class.
that's enabled, and color them.
Okay.
That is really cool.
Okay. So in addition, adding on to that, right?
So coming from another tool, having these classes and being able to enable the radnets of these classes, of signals on these classes, and highlight them and color them is really cool.
Okay. Anybody else have anything else?
Raise your hand and then pause till the microphone
Yeah.
gets to you.
About the unions, you have
Unions.
unions. Can we import them or do something with them in the DRC?
That's the second part. Wait up. What the first part is? What's your favorite?
What's my favorite? My favorite is path classes.
Okay. Okay. So classes are pretty popular. You could just I'll repeat it. Okay. Yeah.
For me, it's roots in the schematic. So you have them in the schematic, and
Okay.
the engineer directly sees what the PCB guy has to do.
Okay. Okay. So then let's move on to the second aspect. What have been some traditional limitations? I mean, you just kind of mentioned something. So we have another right here. Oh, that's good. Close.
I don't know if it's still a limitation, but I wasn't able to have half pads at the edge, constellated pads, I think they're called, without creating errors. So I had to go to production with errors.
Okay, well, that was the concept of the wave violation, right? You can waive a violation now and document it so that you can give it to your manufacturer and let them know this error is okay. I had to put that there. So that's how we worked with that.
Yes, okay, but for me to have a clean checklist is not easy. I have errors, and I go to production with errors. I say a checklist that is not clean, and this is not good.
Well, it puts it in a waved,
Okay.
right? It's clean because it puts it in a waved area, right? So it doesn't put it in the error section anymore. It puts it in an organized waved section that's organized.
Thank you.
Right. And then we'll get you next, Jeremy.
What I miss is a check for creepages, not just clearance,
okay.
not just an air gap,
Creepages?
just a clearance.
Yeah.
Or check something
I've-
against the mechanical.
I've heard that a lot, creepages, yeah. Okay. We'll
Creepages.
talk about that in a second.
All right. Thank you.
Jeremy? And then
Back in the
Jeremy's
back.
in the back. Sorry, because he's been waiting.
I wanted to agree with the gentleman asking about the waived violations. I know you say that there's another column there, but and I suspect he feels similarly. To me, everything needs to be like a green check mark, or to me it means the rules are my rules are set up wrong. So I've had the same problem with castellated pads, and yeah, my preference would be to implement a rule, or sometimes I might do like a special library part that meets that need or something, but then it's just workarounds.
Okay.
But just personal preference, and I suspect other people feel similarly about waiving things.
Okay. Okay.
I would like to have a clearance matrix, like the guy yesterday evening has shown, where you can put easily in the different clearances for different high voltage classes. So you have seen the, who was it? Schatke? He has shown a clearance matrix which he has programmed.
I was preparing for my talk, so I didn't actually see
Okay.
it.
And
But,
we have programmed a similar thing where we can define all the different net classes and put in a matrix the specified clearance distances, and this transforms it into 100 clearance rules at once.
Okay. Okay.
You understand?
Okay. Yeah. That's a little complicated. You had a question as well?
I think one cool feature that was introduced in 19.1, I think, is that you can define directly in the footprint that a pad should be connected without a thermal relief. So this is for us very useful to simplify the DRC rules. So we, for example, for a MOSFET, we define the exposed pad, so the thermal pad, that it should be direct connected and not over thermal relief. We define this directly in the footprint, and not through the design rules.
Yeah, I agree with you there. That's just something that came out recently. I wish I had added a slide for that, because yes, and that you can pick one pad and just say, flood this pad, and that is really convenient when it just needs to be one or two things and not just broadly across the whole board.
Okay. Okay, so, we've found that there are several things that have been coming forward that people have felt kind of limited. Some of them have been brought up. There's some new ones. What you two just mentioned. Well, I've heard what you've mentioned before. What you just mentioned, I haven't heard before. I've heard the disdain of waived violations. I'm okay with the concept, but I'm not producing boards all the time, so Oh.
Yeah, I would have one more question.
Is it about wave violations?
No, it's
okay,
not.
Then
so maybe it's just been me, but if you have like a via stitching between two planes, or between maybe like a polygon and a plane, you have like another plane layer in between, and you have the via clearances.
Okay.
And you place them too close to each other, you will have like a cheese. Like holes of cheese, and you will not have a big enough current path through there. So is there a rule to check for a minimum path on a plane or on a polygon?
That'd be useful on BGAs too, when you've got all the stringer vias integrated into there.
Right.
'Cause sometimes you can really minimize your ground or VCC planes going through there.
So, I want to introduce the 3 new rules for Altium Designer 20. I got you. Creepage, distance, return path check. I'm not sure, it might be able to help a little bit with your issue. I haven't really tested this out yet. Like I said, I focus on Concord Pro. So I haven't tested these rules out yet because we're still developing this. This is currently in beta right now, so I don't try to test anything until we're in open beta, which will be in a couple weeks, just because things change, and I don't want to get to know something until it's solid, right? And then the last thing, this is something I've been complaining about. I tread the line of hardware software engineering, so time-based length tuning, something I've been complaining about for the last 3 years. So finally you could do it based on a propagation delay instead of just the length, which I found incredibly annoying because it didn't make any sense to me when I went into just regular PCB design. For me, it was kind of a foreign concept, because I was always used to thinking of like, my signal needs to get there in this amount of time. So it was really weird for me to go into like, I need this amount of length. It was very foreign for me. So I'm really excited about that. What I want to talk about today, this one? Yeah?
Oh, sorry. Does that mean that you also can set the time in the pin configuration of an IC and not just the length?
So again, like I said, I'm not fully familiar with this. As far as I know, this is in relation to the nets right now. So like the traces. So I would say if you know, just you wouldn't be able to tell on the pin level. Like if you know what that is, you would have to add that plus, you could only calculate it for the actual track.
I can answer the question. In properties panel, this value will be added. It's supposed to be added for pins, so you can take into account this.
So you can take into account
yes,
the pin information?
In length rule, in matched length rule, another mode, in these panels of tuning, and for primitives in property panel, you will see something related like that.
So apparently, in the properties panel, you can put the that information.
Yeah, but this is
The pin information is in length?
Yeah, it's only in length. You have no idea what's the materials. So you must match the time here and with the length in millimeter or in the package. So we must mix match both of them. So this could be tricky.
You have just the relative path, so it doesn't matter how fast it's going there. Just keep it linear.
You must try it.
I mean, we could, I can't answer that myself. I'm not as knowledgeable in that, so I can just tell you the introduction of this. I'm not an expert in that mechanic, so.
Jeremy.
Quick question. Does the creepage distance also work in 3D? Like, can it look at the creepage underneath the part in 3? It can? Yeah?
Yeah.
Okay, cool.
Yeah, that's the first question people ask. So, I was really excited that a lot of people use the parameters from the schematic. That is one of the biggest issues we have seen over the years. That as time has moved on, there are bigger and bigger different rules and constraints are coming from different aspects, right? As the enclosures get smaller, we're working with more mechanical engineers. We have more sophisticated methods of designing together. So there are more constraints coming in from those domains. However, the communication tends to be one way, right? So that's been an issue throughout time. Additionally, rules have generally been very PCB layout centric. Although you can define a lot of things on the schematic, it just goes into the schematic, or from the schematic into the PCB, and that's kind of it, right? You can't really push that information back to the schematic. That's been an issue, so it's something we want to look at and make a little bit better. As we looked at the query language, when you look at something like this, I'm pretty sure no one raised their hand earlier when you asked if anyone does any software engineering, right? Does anyone do any software engineering? There's 2. Jeremy wasn't here earlier. So Jeremy, there were 3 people in this entire room, right? So I would assume this is a little bit foreign to you guys, right? This is not the traditional thing. These explicit priorities are a mess when you have 4 different people working on these different rules. Okay, when I'm coming in as the 4th person that has to add some design rules, how do I know where to add Rule 31, right? Where in that priority list do I add that? That's going to make things incredibly difficult. If I have 1 or 2 people, that's one thing, but when you have multiple authors, it makes it incredibly difficult. And that also is going to make it really difficult to reuse these things. If you first can't read the things you're using, it's impossible to reuse. And when you have this, how am I going to pass it on for someone else to reuse, right? So
that's where we go back to Jeremy's presentation in the last hour is over-document.
Yeah, exactly. So I want to introduce the concept of the constraint manager. This is a complete work in progress. It is an advanced functionality that can be enabled manually in Altium Designer 20. I'll show at the end how to enable it manually if you would like. It is not enabled by default, so if you don't want to use it, no one has to use this. I just want people to have the opportunity, if they want to be able to use it, provide feedback to us. The very first concept I want to introduce is the concept of constraint profiles. So you see here, we have two types. We have the manufacturing constraint profile and the design profile. You see here, we have a little overview and a little where used area. So diving into the manufacturing profile, I have three here American manufacturer profiles. The concept of the manufacturing profile is to validate the rules themselves, right? It's great that I've made a board with a 1 mil trace. Who's gonna make that? No one's gonna make that, right? I'm gonna make this, and I'm gonna give it to someone so that the rules are validated, right? Before we get started with the design. I'm gonna make sure that things make sense before I get started. You see here, everything is valid, right? All of my rules currently that exist are valid and following within my limits, right? The next concept are the design constraint profiles. As Kelly was showing earlier, he needed to define some 90 ohms. I made a constraint profile for an 80 ohm. What this does is, as soon as I add this to a design object, with the constraint manager, it is object-oriented. So now I could add this to a differential pair, and it will automatically apply all of these rules as a baseline. So I can add this quickly to several objects, and it has this automatically, right? And that's my baseline, and I can modify it as necessary and get started very quickly. It makes rules fast and accurately. And this is gonna help with multiple things. It's gonna help with the multiple authors. It's gonna help with the multiple domains and sources, right? And the project reuse. From here, this is the basic rules user experience. As I mentioned earlier, we have the different object types. So you have nets, differential pairs, X signals, polygons, components, and pads. Again, very early, work in progress. We want feedback from this stuff. We want you guys to use it, talk to us. What works, what doesn't work. So just keep that in mind. Design oriented, right? Object oriented. I have this, right? This differential pair. I apply my design constraint profile, automatically create those rules. These were not part of my constraint profile. Nothing's applied. I automatically have that. You can see here, I have applied 3 different rules to that, and it will automatically define my priority based on specificity. I no longer have to worry about prioritization, right? It's automatically gonna take the specificity based on layers, based on information such as room, clearance, all these things. And, right, we wanted to make it as visual as possible. Jeremy.
So does this generate rules that end up in the rules manager? Are they like read only in there, or how does
What?
you talk for that?
To the
The way you would like set up rules now, if
Yeah.
you define something in here, does does that then show up where we currently define rules?
So,
does it push over to that?
As far as I know, they do? Yeah. 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 So the goal right now, this is like the front level. We don't want to change the existing thing, right? It works, but we want to streamline it, right? So this is the new user interface that pushes into that existing ecosystem.
I really like the idea. It seems
Right?
super cool.
Right.
I was just wondering if it's like one or two, like if it pushes to over there and then I give the design to another designer who has no idea if this interface even exists,
Yeah, they don't
and edit something.
and they could work on that one.
Does it then like push back into the constraint editor, or is it override it, or how does that work?
That I wouldn't know, and we would have to talk about which, you know.
Okay, cool.
Because I haven't tried to do that myself. Would you happen to know if you modified it in the like regular design rules, would it? Yeah, I mean, like, it's so early right now, I doubt it'd be...
For now, it's still in progress, so there is not final decision how to treat all of these, but right now, we can possibility to create usual rules here.
Yeah.
But you will see, which is eventually will be exposed.
Yeah, I mean,
haven't finished yet.
this is why we want some type of feedback. I mean, we were going back and forth on whether to show something, but I was like, these are like the most dedicated users, right? Like, let's get some feedback.
So my feedback on what I just said would be having a single source of truth always makes things less complicated. So if this pushes to that, that's cool and awesome, but it should show up in the legacy rules editor as read-only, and maybe it like links back to this, so you can get taken to this to change it here. But I think if you try to have like bi-directional back and forth, it's just going to end up getting more confusing.
Yeah. So I think it really depends on the steps moving forward, right? So, well, we can talk more if you want to try using this. You know, we'll talk in more detail. You know, you can come visit us for a couple days again. You had a question, yes.
Faster.
Do we have two microphones? Can we keep one up here?
Do we have second microphone?
No.
If we use that constraint manager in our scripts, will there be an own API to manipulate the data in the constraint manager, or can we use the same API for setting design rules? Because in my company we use a script to set, for example, the DRC rules for a specific OEM.
Okay.
So we have a list of all OEMs.
I wouldn't be able to answer that right now. Okay. I could provide you an answer after you send me an email asking me that, because I'd have to send that to the product manager. Okay. I will talk about something else being introduced that will facilitate that maybe, but also maybe make some changes to your scripts. So let me just keep going unless someone has some. Right. Okay. As I was saying, this is going to make the multiple author situation easier right here, right? Because you're no longer worrying about the prioritization. It's automatically taking care of that for you, right? However, I know you guys and girls, everyone here, sometimes you like to take a little bit more control. Advanced mode, right? You want to take the priority into your own hands. You could do that still. This area is the basic area. You could take the advanced part into your own control, set that prioritization as you wish. Still available there. I know you missed that syntax. We'll leave it there for you. You can pull up that 300-page manual. I saw everyone was super excited to read it, so you can still pull it up, get involved in there. Like I said, we're just trying to make the usability, increase the usability a little bit, right? What's been added, right? A couple new binary keywords. So we've all seen the concept of same. So we added not same, right? Again, things can change, but that's the basic terminology right now. So things are same, things are not same. Scopes library, my favorite thing. I'm going to go into more detail, but this is what I'm talking about. cross-probing. One of the most important things, as the number of domains increases, the ability to navigate between the rules and where they are located increases, right? Like the need for that increases. So we wanted to improve that. So that's one of the main priorities, being able to navigate between the different areas on both the schematic and the PCB, right? With the basic rule construction, that eliminates the syntax and the problems with the prioritization. The organization on the object level of the rules, simplified here. You can see the rule visibility. As I was saying, we've added this scopes library in order to increase the readability of expressions. So this was that expression Kelly showed earlier. I changed it to less than 2 mil tracks, right? It's a little bit easier to read. I think if I showed that to a lot of people, they would understand this a lot more than they would understand that, right? So you have this concept here where you can replace these longer expressions. You can have someone who is more knowledgeable in the syntax make these scopes and create this readable information. That's just going to make it a lot easier to recreate things, make new rules in the future, and make everything as simple as possible. As I mentioned earlier, this is very, very early thing. You have to enable it. General, advanced settings, it's in the preferences, constraint manager. Very simple. If you're interested in this, please let us know before you do it, just so we can talk about it. This is my name, David Aboud. Michael McSherry is the product manager. I'm available at any time to talk about it, any feedback. I do the product marketing, he does the product management, so I'll help you figure things out. I'll help deliver like how to make it better to Michael, and he can kind of help, help develop the product better. I have a bunch of cards over here, and we'll open it up to questions, but just want to thank everyone for their time. I hope that excited everyone a little bit, but thank you.